So in part B, we are asked to assume that the frictional force remains constant throughout. So that means it is 750 newtons for the entire rest of the journey. Determine whether or not the car reaches the service station. So we know that the work being done by friction is going to be due to the average force times the distance. So we could ask how far could we go? So the distance then is the work divided by the average force. And we have 25 times 10 to the fourth joules of energy. And the average force, so the average force is 7.5 times 10 to the second newtons. So we see these guys reduced to 10 to the second. And 25 divided by 7.5 is 3. So the distance is 3 times 10 to the second meters. Or 300 meters, but we need 400 meters. So determine whether or not reaches the station. The car will not reach the station because the friction work, or the work done by friction will only last 300 meters instead of, we can say which is insufficient, or is much less than the 400 meters to the station. In our next question, besides the friction in the wheels and tires, what's another source of frictional resistance for the moving car? Why will it not, so that's the first part, and why will it not remain constant during the motion? So let's picture ourselves in this car. Well, as the car is rolling along, yes, there's going to be friction between the tires and the road, but the more common one that we think about is air resistance. There's going to be air resistance. So, another source of frictional resistance is air drag, which depends on the velocity. We could even say that the force of drag is proportional to the velocity squared. It's not absolutely necessary, but we want to say that. So as the car slows down due to friction, the drag will decrease. And we want to say due to friction, the force of drag, let's put the word force in there if we can, will decrease.